Welcome back. This is the part 2 of the session on the multi-level perspectives to understanding health. And in this particular part, I'm going to sort of outline what are the key questions, key substantive questions that motivates the application of multi-level models, along with a very brief overview of how do these models look. And it's obviously sort of compressed to give you a flavor for this, and we can follow it up with more readings and discussion on this. The basic idea that I'm going to sort of use for this particular part to motivate what type of research questions does multi-level models allows us to answer. I'm going to motivate with this classic study done close to 200 years ago now on the sanitary conditions of the laboring poor in Great Britain. And if you look at this table, you have on the columns, you have the 3 social class. So think about that as you can define individuals in terms of their social class. So the gentry and the professional are the highest social class, followed by the farmers and tradesmen, and the lowest social class being the laborers and the artisans. On the different rows of this table tells you the different places for which we have the longevity or the average age of death described in this table. So Rutland, Bath, Leeds, Bethnal Green, Manchester, Liverpool are the different places on the rows and the different social class groups on the columns. So if I take any given place, I find a variability in social class. So if I take Rutland, you find that the high social class are more likely to have a higher, longevity is higher among the high social class compared to the laborers and the artisans. I can take any given social class, for example, let's take the low social class, the laborers and the artisans, and for any given social class, there's a dramatic variation in places. So from Rutland is more than twice, has a more than twice longevity compared to Liverpool. And what you find is that the interesting is the sort of the dynamic between the place and the social class. So the dynamics between the place, the context, and the social class, something that tells me my own individual level socioeconomic circumstance, is that if you take, for example, in Liverpool, the highest social class has a lower survival chances than the lowest social class, for example, in Rutland. So it sort of gives us a sort of a view of how both the individual, as defined through social class, and the place, in this instance, not defined at this point, but just identified as places, can have this dynamic interplay between the context and the individual. With that motivation, a lot more has been described in this book, which came out in 2003 or 4. Substantially more work has happened since then, but you get the basic idea for a lot of things that I'm going to be motivating within this book. So this notion, I'm going to be using the example of neighborhoods as one possible context at the higher level, and to link it to health in this particular module. So we get 3 key insights that I want to emphasize here, and it draws from also partly from part 1, the Robinson reanalysis. And I'm going to focus on 3 concepts here that and getting at these 3 concepts, getting answers to these 3 concepts, to these 3 ideas, is, I think, what multi-level models are very, very appropriate for. So number 1 is composition and context. Number 2 I'm going to talk about is contextual heterogeneity. This idea that how do individual relationships vary across context, and finally the interaction between individual level factors and contextual level factors. So what's the idea of composition and context? I briefly alluded to that in part 1. Let's make it a little bit more concrete to get at that. So let's say there are the smoking rates in this slide, as I'm sort of pointing out. The smoking rates are twice higher in place A as compared to place B. We can interpret a place effect based on this. So let's say if we move somebody from place B, which is a lower smoking rate, place B has a lower smoking rate. If we move someone from place B to place A, which has a higher smoking rate, the probability of smoking for that individual who moved should go up. And if that happens, that we can sort of conceptualize as just a sort of a pedagogic way of sort of trying to think about, what would be a place effect. There are multiple ways of doing this. That would be considered a place effect. If I moved you from a sort of a poor to a richer place, and then your outcome changes, that's one way to examine the place effect. And this we call it the difference places make to people, or what we call as the contextual effect. And this is presumably what we are really interested in. Are there contextual effects? Do they exist? And can we identify them in our analyses? And then the second is the people effect. So let's say, yeah, place A has a higher smoking rate than place B, but place A also has a lot more young people than place B, and we know that being young doubles your risk of smoking. So if that's the case, then the place variation is not really due to anything about the place, but more about the composition of the place in terms of its age distribution, which has a strong association with an individual's probability of smoking. So this can be characterized as the difference people make to places, and what we refer to as the compositional effect. So a core purpose, one of the key motivations for applying multi-level models has been to understand this, to what extent variation between countries, variation between villages, variation between communities, variation between neighborhoods, whatever way you define that higher level unit, is it independent of the composition of who lives in those places, or is it dependent on who lives in those places? If it's dependent on who lives in those places, then one could argue that there is no real direct role of places in influencing those health variation. It's being influenced by differential distribution of risk factors. So this idea of testing, the separating out, the disentangling the compositional part of the geographic variability from the contextual part of the geographic variability is a core aspect of applying multi-level models. Before I sort of talk about 3 models that I'm going to discuss, 3 or 4 models that I'm going to discuss, you can also define what do I mean by a contextual effect. So I can define contextual effect in 2 ways. What we called one of them as the common ecologic effect. So in this particular instance, I can ask a very general question. Do places matter? I don't know anything about these places per se in terms of their attributes or what they have, what's the pollution. I don't have any information, but I just want to ask the question, is there an effect of places? And multi-level models offer a way to answer those. Or I can also go further and ask a more specific question around a common question like, does living in Boston, is that better than living in New York or some other place? And that's a sort of, it's still, I've not defined what about Boston is just different or better, but I'm just asking that general question. And that we tend to call as a common ecologic effect. So just identifying, do schools matter? Do neighborhoods matter? Or is this neighborhood more better than the other? And the second a type of ecologic or contextual effect is the specific effect. So where I measure a specific attribute of a place. So let's say I have a sample of 50 villages and I can measure, let's say, aspects of social cohesion or aspects of social capital in each of those places. That would be measuring an attribute of that place and understanding the association between that place level attribute and the outcome. So we can define the contextual effect in both a common way and as a specific way based on an attribute. So what do I mean by a common effect? Just sort of trying to illustrate that. So one question that motivates that type of sort of a framework is, after adjusting for individual and area level confounders, is there variation between places in BMI? So in this slide, as you can see, on the x-axis I've just plotted 2 groups, the low socioeconomic status and the high socioeconomic status. On the y-axis it's a body mass index, because a lot of the in-depth sites are still in the low middle income country. Often in these countries we still find that the high SES SES tend to have a higher BMI than the low SES. So the dark lines, not the symbol lines, the dark lines represent the average BMI for the high SES and the low SES. And what you find around those lines are those symbol lines. And there are two aspects to those symbol lines. Here I have only represented 6 symbol lines just to sort of keep things more illustrative and clear. So think about them as 6 places, 6 sides. And what's shown in this thing is that, of course, there's a variability around that average, but the variability is the same for the low and the high social class. Number one. Number two, the ordering of the places is also the same for the low and the high social class. So such that the slash, the forward slash place, the line showing the forward slash space, they are lowest BMI place for both low and high SES. So there is a geography of BMI. Places do matter, but they matter in the same way for everybody, both for the high and the low SES. We can test whether that's true or not by developing what we call as the random intercepts model. The basic concept of a multi-level model is to write models at every level of your analyses. So you write a model in this particular example. Our structure is we want to model the variability in individuals and the variability in places in BMI. So we have a micro model at the individual level that we specify, and then the macro model at the place level. So in the individual level model, we put variables like x1, which is the individual SES, because that varies between individuals. So let me sort of read out the micro model. You can think about the y as the BMI of an individual I in place j, which is the subscript for BMI. That's your structure, the contextualized structure, is a function of a constant. So that's the x0. So that gives the intercept parameter for every place. And x1 is our SES variable. So I can get an effect of how much of the variability between individuals is accounted for by the differences in individual SES and the E0ij, a residual term at the individual level. Then I write an equation at the macro level, the between place. So the beta 0j that you see there is the average BMI for place j is a function of the average BMI across all the places, and then U0j, which tells me some places are higher than the average and some are lower. We basically combine these two, we substitute the macro model into the micro model and then do the little algebra, and then we get a combined model. So basically when you run the model, this kind of a statistical, this is what we call as a random intercepts model, what you get back are the following. So you get the beta 0 and beta 1, which gives you the average association between SES and BMI. Then you have two sets of residuals, the U0j and the E0ij. So the U0j, we make the assumption of independence and identical distribution, the IID assumption, the normality assumption, and we can summarize that distribution in the parameter sigma square U0, which estimates the between place variation after accounting for individual SES. And then similarly at level 1, we have the level 1 residual, the E0ij, which again we assume an IID distribution and summarize the variance in sigma square E0. That gives us the between individual within place variation. So as you can see in a very sort of a quick way, that what we have done is we have partitioned the variation in BMI into two components. A component that is due to individuals, a component that is due to places. And once you separate them out, then you can very clearly distinguish how much of the variation is due to places or is due to individuals, how much of the place variation is explained by the composition of the SES, of the individual composition, and so on and so forth. What makes it a multi-level model is the presence of more than one residual term, a residual term that tells you about the place and about the individuals within that place. And that's the new parameter that we get. As I've already explained, that sigma square U0 tells us how do places vary. If that is non-zero, then you say, okay, places vary. And then a follow-up question would be, is that variation explainable by some place level factors? And we'll get there in a moment. But we can also ask, is place 1 different from place 2? Or what is the specific effect of a place? I don't want to go too much into the details of this, but what I'm showing there you is a formula of how the multi-level model calculates that specific place effect, the effect of a specific neighborhood. So having estimated the overall variation, we can make predictions for specific neighborhoods to get at the effect of each neighborhood. And obviously we do that under some, this is the sort of the engine part of the multi-level models. Very quickly, the point that I want to get across is, the main point that I want to get across is, can be probably be illustrated through that, the check diagram that you see there, those boxes. Think about each of those cells as a place. So what you see there is there are about 12 boxes there. To the 12, there are 12 places. In multi-level models, we are not modeling one place at a time. We are modeling the distribution. We are saying that these 12 places are one realization from the possible population of neighborhoods or places, and that's what's shown on the graph, on the picture above that, that table, the cells, which is the distribution. That's what we are modeling. We are saying that we can summarize the variability of those different that you see with the mean, which is your betas, and some variation around it for the neighborhoods, which is the sigma square U0. There are some additional notes there. I don't want to get into the sort of too much in the detail. Taking this approach offers us some advantages, and that's what listed on the slides there. So keeping the focus on the sort of the substantive aspects of multi-level. The second aspect, going beyond the random intercepts model, allows us to answer that compositional versus context question. The second question that we would like to answer, which brings in the contextuality, is, does the association between SES, individual SES, and BMI vary by places? And the same picture there here in terms of the broad legend to that. But what you see here is we have modified. So this time I'm showing that the variation between places is much greater for the low SES, while it's much tighter for the high SES. So it matters less which place a high SES individual lives. Number one. And number two is the ordering. And what I have completely flipped in order to sort of get across this message that both the amount of variation and or the ordering of places could be different. And together they tell us about the underlying geography of the BMI by social class. And that's the key idea that's presented here. So even if you're only interested in individual level associations, the fact that it might vary from place to place is an important question to bring in the contextual aspects. Are those associations contextualized? As we saw in the case with the Robinson example, they certainly were. And in many instances, that's exactly what you find, that the average effect at the individual level that we often report usually have a dramatic variability, especially when we look at in-depth sites. You might want to think about the same risk factor exposure outcome association having different magnitude depending on the different sites. And that tells us something about the uniqueness of some of those sites, at the same time allowing us to generalize across those sites. And again, these can be implemented in a slightly more complex model. I don't want to get too much detail into it, but essentially what we are doing here, if you just focus on one term, is the term that U0J and the U1J. So which is, now we are saying that the effect of SES, which is in beta 1 in that slide, varies from place to place. So what term is capturing that variation is the U1J. So you're saying that the overall effect of SES could be more stronger in some places and less stronger in other places. And we capture that in what's referred to as the random slopes model. So in those two cases, what I would argue, we have not brought in a place level attribute. We have modeled contextuality broadly in terms of thinking about places or about a specific place, but we have not come up with an attribute of that place. So we can extend those two models to thinking about the following. So if there is place variation, If there is place variation, then we should be able to explain it, or at least that's the goal, is to then explain that place variation, not using just an individual level variable, but a place level variable. So for example, in this slide, we show that is there an association between the affluence of a particular place and the BMI. So the affluence of a particular place is a place level characteristic. So in this particular graph, we just show a main effect. So there is an effect of individual SES, but there is also an effect of place affluence. So richer the place, higher the BMI. And this can be again specified within these multi-level models in the following way. The main take-home message from this slide again is the focus on the macro part of the model. So the place attribute goes in the macro part of the model, because a place attribute cannot explain within place variation. It can only explain between place variation. Within a place, that place attribute is exactly the same for every individual within that place. But as place changes, that can change. So place attributes, hence you need the micro and the macro model. You cannot have just one model and have exposures measured at level 1 and level 2. And finally, you can think about a cross-level interaction where there is a differential effect. The effect of place affluence depends on the individual SES, or vice versa. The effect of individual SES depends on the contextual affluence of a particular place. So in this instance, we just show a very opposite relationship where if you're high SES individuals and living in a very affluent place, you're more likely to have a higher BMI, while for the low SES, it reduces their BMI if they tend to live in a very rich. Just one illustration. So an interaction between a place attribute, an individual attribute, and how it impacts the outcome. And again, we can implement these models, and what you see here is it's the interaction term here between that x2j. You can think about that as the place influence, and the x2j times x1ij is the interaction variable. If you come across different terminologies, obviously given the time constraint and the focus here being on the substantive aspects of multi-level perspectives, but if you come across all these different names, the hierarchical models, variance, covariance, components model, random coefficients model, mixed models, multi-level models, they are essentially technically the same thing. Okay, so in summary, the multi-level models provide a very comprehensive framework to modeling contextuality, and it does so by also considering the individuality. So modeling context is one of the main sort of utility of the multi-level models, which is the main message that I want you to take home from part 2 of this particular session.